Now let's talk about series and parallel circuits. And so we defined cathode and anode so that we can talk about, well, how are series and parallel circuits arranged by using this description of cathode and anode. And for both of these cases, I'm going to draw electrical current. We're going to say the electrical current flows downward in both cases. So in series circuit, we'll talk here, we'll go, the electrical current flows down. All right, so if I wanted to set up a series circuit, the definition of series circuit says the cathode of one electrical device is connected to the anode of another electrical device. So let's start with one electrical device here. It's just a resistor. And if I put it over here, well, the cathode is where the electricity leaves this device, and it's down here on this end. And the anode is where the electricity enters the next device. And so if I were to grab another device, you would see that my two devices are in series. And that's because this is cathode and this is anode. And they're connected. Now, these two devices are in series, and we can say that based on this cathode and anode, or we can just say, look, they kind of go in order like a series does. The electrical current flows in one, out of that one, and then into another one, all in a row, like a series. Okay. The next type of circuit that we have is a parallel, and this one's important to look at how it's worded. It says the cathode of one electrical device is connected to the cathode of another electrical device, and here, see the and let's make that important. And the anode of the first electrical device is connected to the anode of the second electrical device. So these need to be connected electrically. Okay, so if I have two devices and I want to put them in parallel, well, the easiest way is to stack them horizontally, and then we connect them with a wire. Once again, my current flows down, and so that means that these two sides are the anodes because the electricity flows into them, and then it's going to flow out the cathodes right here. And so these two types of devices would be in parallel because my cathode and my anodes are connected. So this is an anode, that's a cathode, and that's a cathode. And so that makes these two devices parallel. Another way that you can look at this is that they are kind of parallel in my screen here. Now those are basic circuits, but I want to look at one more thing, and that is what happens if we have circuits that are not basic. All right? What happens if we have circuits that look like, let's leave this, let's move this back. All right, let's say that I have this kind of circuit. Move this right here. Let's grab one more wire here, and we'll finish this circuit off. Okay, well, now if I were to label my cathodes and anodes, well, this is an anode, and that's a cathode, anode, cathode, anode, cathode. Okay, well now I notice that, well, I do meet the criteria for series. I have a cathode connected to an anode, and that makes it this right here. These two resistors, or these two components, are in series. But if I look here, this resistor over here on this lonely resistor on the side, well, it kind of looks like it would be in parallel with this resistor right here, but it's not. And the fact that my anodes are connected, yes, but this big and right here is not being fulfilled. The cathode here has to be connected to the cathode there. Instead, this cathode is connected to the cathode down here. So these two, let me go ahead and change my color. These two resistors are in series. Okay, and they follow the rules. But instead, those two resistors are in parallel with this one resistor. So this resistor is in parallel with these two resistors in series because the anodes of these two, the top two, are connected, and the cathodes of the bottom resistor and the cathode of the lone resistor are connected. And so that makes this series in parallel with this resistor. So keep that in mind when we start doing circuit analysis, that A series can be in parallel with another resistor. Also, you can have a parallel in series with another resistor,